In this video, we're going to talk about ionic compound nomenclature. And so all that simply means is how we name the naming of ionic compounds. All right, so before we get to that, first we're just going to quickly review what are ionic compounds. So ionic compound is basically where you have a metal that's bonded with a nonmetal. Now, this type of bond, we call them an ionic bond, all right? Ionic bonds are created due to the difference or the opposite, the attraction to opposite charges. So we know that typically metals, they form positive ions, while nonmetals, they tend to form negative ions. And so because of that, there is an attraction between those two, all right? And this attraction will create what we have here, this ionic bond, okay? Now, all ionic compounds, key note here, because of this, all ionic compounds are neutral, okay? And so this really is important when it comes to naming ionic compounds or naming ionic compounds and writing their chemical formulas, okay? So the idea that, remember, it's always neutral. All right, so let's go a little bit deeper into this. Okay, so the first type of naming I'm really going to talk about is what we call type 1 nomenclature, all right? So now type 1 nomenclature, basically we're just talking about ionic compounds, all right? And as we said earlier, ionic compounds are between metal with nonmetals. Now, what makes type 1 really kind of special versus all the other types that we're going to talk about a little bit later, type 1 metals are very specific. So when we talk about type 1, we're talking about first the alkali metals, all right, the alkaline earth metals, and then we're also talking about aluminum, indium, and gallium. All right, and so we're talking about these group of metals. So remember, the alkali metals are your like lithium, sodium, potassium, rubidium, and so on and so forth. Alkaline earth metals, example, magnesium, beryllium, calcium, and so on and so forth. So group 1 metals here, group 2 metals here. And then you have aluminum, indium, gallium. And why we're talking about these metals specifically? Because type 1 metals are basically metals that only have one specific charge, or what we typically call oxidation state. An oxidation state just simply means the charge of the atom. So these metals only have one. So like we talked about earlier, that all alkaline metals has a positive 1 charge. All alkaline earth metals have a positive 2 charge. Aluminum, indium, gallium, these guys all make a positive 3 charge, okay? So because they only make 1 charge or have 1 oxidation state, we call this the type 1 nomenclature, okay? So let's just kind of practice going from chemical formula and writing the chemical names themselves. Okay, so for example, let's say we have this formula here. We have NaCl, okay? So a couple of things that I want you to notice from this. So first, you will see that metals are written first, okay? That's standard, and that's expected, okay? Secondly, you will see nonmetals are written second, okay? So that's always the case here. Now, when it comes to naming them and writing the name from the formula itself, when it comes to the metals, okay, you always write its full name, okay, always. So in this case, we have NaCl. So Na, the name of this is just simply sodium, okay, when we write the name itself. Now, the chlorine is a little bit different. So the nonmetal will use the suffix "ide," okay? And really, you kind of drop the ending of the actual name of the nonmetal and you add "ide" to it. So in this case, you have for chlorine, it will be known as chloride. All right, so here's your suffix. So you kind of keep the root. General rule, it doesn't always work out this way, but the general rule that for the nonmetal, you keep the root, the first syllable, and then you add "I" to the end. So like chlorine, chloride, okay? So that's the way it kind of works with this. So in this case, just to kind of review what we just talked about. So once again, you have the metals always written first. All right, so we see here with sodium. Then you have the nonmetal that's written second, so we have that with chlorine. And then the metal always keeps its full name, so we wrote it as sodium, while the nonmetal, all right, will have "ide," okay? And so here we have chloride. So the full name of NaCl is sodium chloride. All right, let's just go through a couple more examples. So for example, let's just say we have AlN. Okay, so here's a ionic compound. All right, aluminum, which is a metal, nitrogen, which is a nonmetal. So when you write out the name, you have aluminum. All right, and then you have the N here. So remember, we keep the root in a sense. All right, and then we add "ide" at the end. So here is what we call nitride. So this compound is called aluminum nitride. Let's go through more examples. So let's say we have Li2O. Okay, so Li2O, you first have lithium. That's your metal. Okay, and then you have your O here, and so we just write oxide. So instead of oxygen, we have the suffix "ide," so it's lithium oxide. Now, oftentimes, a temptation that you have some students who will have, they'll try to include something with this too, or something with the subscripts, whatever the subscript it may be. All right, and when we're talking about type 1, or basically all ionic naming, we never include the subscripts within the name itself. You just look at you could kind of ignore it when you're naming it. And you just write the elements as you see it. So here's lithium oxide. Another example is that you have, let's say this. So Ga2S3, okay? So Ga, we know is gallium. And then we know that S, all right, is sulfur. So instead of sulfur, we have sulfide. So here's the chemical name for Ga2S3, gallium sulfide. And so that's pretty much it, okay? So just to kind of quickly just review this, all right? You always have your metal always comes first, okay? Then you have your nonmetal, and when you're naming it, the metal name always remain the same. So you have gallium in this case, and then the nonmetal name, you always change the suffix to "ide," okay? And that's the way you name them, okay? So now let's work backwards, going from the chemical name to the chemical formula. Now this one takes just a little bit more thought. So here now I have the periodic table kind of pulled up right next to us, so that way we have something to reference on, and you'll need a periodic table when you're going from the name to the formula itself. So one key thing that you have to remember about ionic compounds is that ionic compounds are neutral, all right? There's no charge to them. And so the way how the formula is written, it helps us, the way it's written, you need to know the charges of each of the metal and the nonmetal so that you know the ratio of each that is needed in order to make a neutral compound. And always a neutral compound is the lowest ratio of the two ions bonded together, all right? So as I said, once again, you have to think about that the fact that it is neutral and that you're dealing with two charges, okay? So for example, let's say we're looking at this element. We want to write the formula for lithium fluoride, okay? So the first thing you want to do is figure out what is the charge for each of the ions. So what's the charge of the metal and what is the charge for the nonmetal? So if you look at the periodic table here, that you find, okay, here's lithium, okay, here's fluorine. So we see lithium. For lithium to have a full valence shell, it needs to lose one electron. So when it loses one electron, it will have a +1 charge, okay? And then fluorine, for it to have a full valence shell, it needs to gain one electron. And so if it gains one electron, it's going to have a -1 charge. So these are your charges, okay? Now, once again, I said that the compound has to be neutral, all right? So if that's the case, if you look at this, you have a +1 charge here, and then you have a -1 charge here. And if that is the case, then it's basically a 1-to-1 ratio. And 1-to-1 ratio will give you a neutral compound. And so we just simply write it as LiF, all right? So lithium fluoride, the chemical formula for it is just simply LiF. Let's do more examples, all right? Let's say we have magnesium chloride, okay? So let's look at the periodic table and let's find magnesium and chlorine. So magnesium is here, okay? Chlorine is here. So what we notice is that for magnesium to have a full valence shell, it has to lose 2 electrons to look like neon, right? So this will be a +2 charge. For chlorine to have a full valence shell, it needs to gain 1 electron to look like argon, so it will have a charge of -1. All right, so now we have, this gets a little bit complicated. Well, not too complicated. But here we have magnesium that has a +2 charge, chlorine that has a -1 charge. And once again, you need the correct number of each of the elements, all right, so that you can have a neutral compound. So the way I kind of think about this, and just a little bit of math to this, but this works every single time, honestly. All right, when I'm looking at these numbers, 2 and 1, what I typically figure out is, okay, what is the least common multiple between the two? All right, so what number can both 2 and 1 go into, or the smallest number that both 2 and 1 could go into? And that number is simply 2. All right, so how many times magnesium 2 goes into this 2? Well, 1 time, so I will write Mg. And how many times chlorine will go, or chloride will go into 2? Well, hopefully you notice that it will go there twice. So you will write Cl, and since it will go in twice, you will have the subscript 2 to show that there's 2 of them. Now, does that kind of make sense? Yeah, so like if you think about it, right, you have this Mg that has a +2 charge, okay? And so for this to be completely neutral, you need 2 chlorides. So both these chlorides will have an overall negative charge of -2 to cancel out this positive charge here. So it's MgCl2, all right? Let's go through a couple more examples. All right, let me erase all this. So let's say we have, let's say we have potassium sulfide, okay? So now potassium sulfide, if you look for potassium, it's here. Sulfide, which is sulfur, is here. So for potassium to have a full valence shell, it needs to lose 1, so thus it's going to be a +1 charge. For sulfur to have a full valence shell, it needs to gain 2 to look like argon, and so you'll have a -2 charge, okay? So same idea, what I typically like to do is find the least common multiple between these two numbers here, between 1 and 2, all right? And so what number, the smallest number that both these numbers will go into evenly, and so that will be 2. So how many times potassium will go into 2 with this +1? Well, we know that potassium will go into it twice. And how many times sulfide will go into 2? Well, sulfide will only go there once, so it's K2S, okay? Let's do another one. Let's say we're looking at aluminum oxide, okay? So for aluminum oxide, you have aluminum is here, oxygen is here. So we see that for aluminum, when aluminum becomes an ion, it's going to look like neon. So it's going to lose 1, 2, 3. So that's a +3 charge. For oxygen to be an ion, it's also going to look like neon, but it's going to gain 2. So it's +3, -2. Now, to write the chemical formula, as I said, I typically like to figure out what's the least common multiple between these two numbers here. So 3, 2. So what's the smallest number that both 3 and 2 will go into evenly? And that number will be 6. Usually you just kind of have to multiply them. All right, so if it's 6, all right, so how many times aluminum will go into 6? You'll see that it goes in there twice, so it's Al2. And how many times oxygen goes into 6? And so you will see that hopefully it is 3. So the chemical formula for this is Al2O3. All right. And then let's just do one more example. All right. So let's just say we have calcium nitride. Actually, let me just erase the rest so it doesn't look too messy. All right. So we have calcium nitride. Now look for calcium and nitrogen on the periodic table. So hopefully that you see that calcium is here, nitrogen is here, all right? And we see that calcium, when it becomes an ion, will lose 2 electrons to look just like argon. So with this +2 charge here, nitrogen will gain 3 electrons to look like neon, and it will have a negative charge, not a positive, a negative charge here. So I always look for the least common multiple. In this case, the least common multiple between 2 and 3 is 6, okay? How many times calcium goes into 6, or how many times 2 go into 6? It goes in there 3 times, so Ca3. And how many times nitride goes into 6? How many times 3 goes into 6? And it goes there twice, so it's N2. So your overall answer at this point is just really simply Ca3. Ca3N2, I'm sorry, okay? And so that's it about type 1 nomenclature.